So for the past couple of months, I've been working on a Super Mario Bros. Remake. I'm not quite finished, but I'm going to show you guys what I've got today and go over some of the key concepts involved in creating this game.
What?
Alright, the first thing I want to mention about my game is that I created it using C++ and SDL. All the background music you're going to hear in this demo is handled in a separate thread. I chose to implement it in a separate thread because I wanted more control over my music. So if I get to the flag, or if Mario gets to the flag, or if Mario dies, I want the song to either pause or change to the next track and whatnot. Oh, and the part I'm still working on for this game is the level editor. I'm not finished with that yet. Oh, and you're gonna notice that I have some non-traditional characters in this. Or Mario can also double jump. And the boundaries for Mario are actually smaller than they should be. So you'll notice if I go up to a wall, his hand goes over like this, and vice versa on this side of the wall. I do this so that when I come up to tiny gaps like this, I can go down. Because normally if I just use like the boundary of the picture boundary is going to be too large. Because right now the Mario's boundary is about 70 pixels wide, which is too large to fit down this 50 pixel gap. I'm gonna die right now just to show you the effects for that. Okay, let's try this again. So you notice the track changes.
What?
Okay, if you notice, when one TNT box goes off, they all go off. I do this by checking upon destruction on a TNT box. I do this by checking the surrounding area for other TNT boxes. I'll go over boundary collision pretty soon. Alright, well, that's it for the first level. Now I'm gonna go over what it took to create this game, and I'll start with polymorphism. Hope you enjoyed.
What?
Alright, so the first thing I want to mention about my game is its use of polymorphism. I use polymorphism because all the characters in my game, whether it be Mario or a Goomba or the bricks, they all have certain characteristics in common. Like, they all have to be able to run at the screen. A lot of them have gravity. Others have to be able to move left and right. And there's all these common characteristics that they share in common. So what you could do if you want to create a game is create an abstract base class. In my case, I create a class called entity, which contains all some of the common data members which they all share, like velocity or like the boundary for the character and whatnot. It also contains the common functions they all share, like show, which in this case I made pure virtual because every single character has a unique show pattern. So also I have other functions which aren't virtual, like gravity, which for all the functions it's going to be the same. So I write it once in my base class, and then I use it over and over and over again for all the characters. And there's other functions like moving left and right, which some characters don't have to move at all, so I don't have to override it. So it's just virtual, not pure virtual. So this is polymorphism in my game. Here's an example for mushroom. So mushroom has certain things I want to override and certain things which I don't override. So there you go. There you go. Alright, the next thing I want to mention is how I chose to store and access all the characters. The key thing to know about my game is that you only need to care about everything that's near Mario. For instance, I don't need to know what's happening to a character that's on the other side of the map. It's not going to affect Mario. I only need to consider things that need to be displayed to the screen or might need to be accessed barely off the screen. Like if this TNT box is exploding, I need to keep exploding even off the screen by a little bit. So with this in mind, I store everything into a vector of list. And I set up this list by dividing the whole entire map into buckets of 50 pixels wide, and then inserting each character into the appropriate bucket. So as an example, if this were a bucket, I would insert this brick, this Goomba, this other brick, and exclude the Pac-Man because the Pac-Man lies outside the range of the bucket. So now from here I could access all the characters I need to perform calculations on that are near Mario in constant time because a vector is implemented as an array under the hood, which allows for constant access and stuff like that. For whatever data structure you use for your game, try and pick the fastest possible. I originally implemented this with maps, not thinking, and maps have lookup time of login. It's not a big deal, but if you could rewrite it as a vector or a hash map or something like that, something with a constant lookup time, you could get faster. You can make your program slightly faster. So here's how I use this data structure in my game loop. So basically, what I did was I set up a beginning and ending iterator to the buckets I should display or run calculations on near Mario. And then from there I could run calculations like functions like move or show or gravity or something like that. And the key thing to know is that because I'm using buckets, I have to reset the bucket if the character walks outside of its bucket. It won't happen, but it won't happen much, but for certain characters it happens. So like if Goomba walks outside of this bucket right here he's assigned to, I have to reset it. So that's why you see me calling set bucket. And one question you might ask is, what if some sort of function is only applied to a character? How do you know which character is which if you are casting it as a entity pointer in your list? And the answer is, upon construction of each character, I assign an ID, which I implemented the ID as an enumeration under the hood. And the good thing about using enumerations is that it allows you to use switch cases, or they can be used with switch cases, which as a good programming practice, you want to use switch cases as much as possible, as opposed to an if-else statement, because upon compilation time, an if-else statement is going to be it's going to have a O of n time as the worst case scenario, whereas a switch case at the best case scenario it will have a constant time because it's implemented as a jump table under the hood, but it sometimes might be implemented as an if-else statement under the hood or a binary tree. But it really all depends on how you write it. But just consider that when you're writing code. Next thing I want to mention is called the active characters list. It's very similar to the list I just mentioned, or the vector list I just mentioned, to store all the characters. But this list is designed for storing characters which have a timer, a deletion timer for them. So, for instance, when Mario shoots a fireball, I expect that fireball to be deleted within 90 frames of the game. So, rather than needing a beginning and ending iterator, this list just runs every single object that's pushed in it. Which, at the moment, I just pushed fireballs on it, but in the future, I want to add TNT boxes and anything which has the deletion timer I just mentioned. Okay, the last thing I want to mention is my boundary collision functions. So before I mention anything about my collision functions, I want to explain that I don't even have to call them for every single object. I only have to call them for a select few. So if I want to see what objects this Goomba collides with, I only have to check 2 buckets to the left and see what objects I might interact with there, and 2 buckets to the right and see what objects I might interact in these 2 rows, and of course the row that the Goomba is applied in. And so now on to the functions. So if I want to just see if there's a general interaction or if there's no interaction, I would use something like this function. It only returns true or false if there's an interaction. If for other cases, I might want to see what side the collision is taking place. For example, if Mario jumps up and hits this box, I want to see if it's the bottom of the box, not like the top of the box or something like that. So for something like that, I might want to use a specific side collision function. For other cases, I might want to use like a radial distance. I don't recommend this because it's kind of slow. Because if you square root functions are very slow computationally, so if you can't avoid them, in fact, you can actually approximate the square root function as as some sort of like funky number to multiply it by. I couldn't find the link, but I learned about it in a graphics class. Anyway, so if you can, try and avoid a costly function like this, but in the case of my Pikachu function, I just wanted a more accurate radial detection. So when Pikachu does that lightning storm, or the lightning ball, I want to see if the radial distance between Mario and the ball is a certain distance. So before I close off, I just want to mention that I said you want to avoid switch statements. I mean, if-else statements like at all costs. But you could say I had them here. I mean, there's no avoiding if-else statements. They're going to be everywhere. But in the case of my collision function, I made it so it checks the boundary wise first, because that's going to be more probable in determining whether or not there's a collision. So I don't have to run like through the whole code. It'll most likely break after these 2 things. Same thing goes with this as well. So even if you do write if-else statement, you could write it better so that it's on average faster. Anyways, that's it for my game. Hope you have some good ideas of where to start.